Problem number 20, we're given a table of values and it includes a bunch of values for g and g prime. We are told that g prime is continuous on 2 to 6, which is good, but we're only interested in the integral from 2 to 5 of g prime of x dx. Alright, well, the integral says first thing we do is take the antiderivative. This is our fundamental theorem of calculus. So the antiderivative of g prime of x will be g of x. And that's going to be evaluated from 2 to 5. So using our fundamental theorem of calculus, we want g of 5 minus g of 2. Well, g of 5, here's 5. Here's g. They intersect at the 15. G of 2, x is 2. G rho, 10. So we have 15 minus 10. Our final answer is 5. For number 21, we have the integral from 0 to 2 of 3x squared plus 4x plus k dx is equal to 20, and we're tasked with finding the value of k. We're going to handle this like we've handled all the other problems. The only difference is that the variable is located on the left side instead of trying to figure out what the right side is equal to. We know what the definite integral is equal to. It's equal to 20. So here we go. 3x squared, the antiderives to x cubed. 4x is 2x squared, and k is kx. K is a constant, so we're just adding an x after it. Alright, that's being evaluated from 0 to 2, and we know it's equal to 20. What number do we plug in first? The 2. So we have 2 cubed plus 2 times 2 squared plus k times 2. And now that's grouped together, and we're going to subtract what happens when we plug in 0. 0 cubed plus twice 0 squared plus some number times 0. That's all going to 0. And we know this is equal to 20. Well, now we have one equation with one variable, which means we can solve for it. 2 cubed is 8. 2 squared is 4. Doubled is also 8. So we have 8 plus 2k is equal to 20. That's 16, so we'll subtract 16 from both sides. So 2k is equal to 4, which means k must be equal to 2. With number 23, similar idea, trying to find k, but again, this time k is in our bound. Okay, well, we're still following the same pattern we've done everywhere else. We're using the fundamental theorem of calculus. 2x, antiderivative is x squared. 6's antiderivative is 6x. That's being evaluated from 0 to k and is equal to negative 9. What do we plug in first? The k. So we have k squared minus 6 times k, and then we plug in 0. So that gives us minus, and we can see, as I told you, 0 is your new best friend. 0 squared minus 6 times 0 is 0. That's equal to negative 9. Alright, so we have ourselves a quadratic. We see k squared. When we want a quadratic, we want to set it equal to 0. So we're going to bring the 9 over to the other side. We're going to add 9 to both sides. Doing so gives us k squared minus 6k plus 9 equals 0. This is a quadratic, so if it factors, well, it'll factor nicely into a product of two binomials. We need two numbers which multiply to 9 and add up to negative 6. Negative 3 and negative 3. Our lead variable is k, so we have k minus 3 times k minus 3. That's the same thing as k squared minus 6k plus 9. Alright, well, what value of k makes this statement true? There's only one. And that's if k is equal to 3. There's our answer. Okay, last but not least, we're told that g is the derivative of f. Right? If g is the derivative of f, we can think of this as the integral from 1 to 2 of f prime of x dx. We're being asked to solve that. What do we do first? We take the antiderivative. The antiderivative of the derivative of f is just f. And that's being evaluated from 1 to 2. Which one do we plug in first? F of 2. Then we subtract f of 1. So we got to plug 2 into the function. So up here we have 2 cubed minus 3 times 2 squared plus 2 times 2 minus 1. So that's 8 minus 2 squared is 4, tripled is 12, 2 times 2 is 4, minus 1. 8 minus 12 is negative 4, plus 4 is 0, minus 1 is negative 1. So f of 2 is negative 1. Minus, now we plug in 1. So when we plug in 1, we have 1 cubed minus 3 times 1 squared plus 2 times 1 minus 1. 1 cubed is 1. 1 squared is 1 times 3. 2 times 1 minus 1. 1 minus 3 is negative 2. Plus 2 is 0. Minus 1 is also negative 1. So we have negative 1 minus negative 1, which is better known as 0.